Okay, so let's have a look at some questions now. So in example 1, the figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates of P are x, y. Which of the following is true about the cosine of theta? So let's zoom in here. First thing we note is that this is equal to 3. So the coordinates of this point here are going to be are going to be 3 cosine theta, 3 sine theta. So what are we looking at here in our question? We have to look at what is, so all of these, firstly I'm seeing here is all of these are cosine values. So I'll just go back up here, the cosine of theta. So what have we got then? We have got the cosine, we have to find the cosine of theta. So it's going to be, if we divide this, the cosine of theta is going to equal, and this is x, this is 3, this is y, this is x, y. I think this is easier. So the cosine is the adjacent over the hypotenuse. So that's going to be x over 3. So the correct answer has to be A. X over 3, because it's the ratio of the horizontal displacement of P from the y-axis to the distance from the origin. Okay, the figure shows the unit circle with radius 5, centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. Which of the following, find the following values, sine theta. So the figure shows centered in angle measure. So here we have our theta, like this one. So what we need to do for this one is, if we look at this vector here, so I'll just draw it like that. This is equal to 3. So this vector is the same vector. This vector here is the same vector. I use the word vector because we're interested in the sign as well and the direction. So it's moving to the left or it's moving up, it's positive. If it's moving down or it's moving, if it's moving right or up, it's positive. If it's moving left or down, it's negative. So this is 3, which means that the coordinate of the x coordinate here is going to be 3. Let's look at the y value. So this vector here, this vector here is 4. This vector here is reflected downward, so it becomes minus 4. So the y coordinate here is minus 4. So what is the cosine or the sine of theta? Discuss with the person next to you. What is the sine of theta? Okay, so what is the sine of theta going to be? Negative 4. Why do you say negative 4? Because the y value is negative 4. So Sam has a good start, a good idea. He's using the unit circle and saying that this is always the sine value, and likewise the blue one is always the cosine value. Now, one thing to remember when problem solving is that all sine values, this is really important to help you catch mistakes. a sine value is always going to be between -1 and 1. Now, is -4 of greater magnitude than that? So you're wrong. What has he got wrong? He's using his understanding of the unit circle. Now, is this a unit circle?
No.
This is an enlargement. Where has the unit circle been enlarged? The radius is 5 here on this one. So this length here is also 5. So how do we make -4 5 times smaller? Divide by 5. So let's have a chance for redemption. What is the cosine of theta? Sam? 3/5. Then the tangent of theta. Who can help me with the tangent of theta? Sorry? -4/3. Okay, next question. Next question. Let's have a little look. So the first thing we want to do with this question, what we're looking at the question here is we have to find points Q, R, and S. John, Sam, we have to find points Q, R, and S. So we have to basically reflect using symmetry these points around. So this vector here, this vector here is going to be y. This vector here is going to be y. This vector here is going to be -y. This one here is going to be -y. This vector here is going to be x. So this vector here is also x. That makes this vector here -x. And this vector here also -x. So just reflecting our points around, we go backwards over here, we get -x, y. We bounce them both down, we get -x, -y. And here we get x, -y. Those are our points, P, Q. I won't write them there. So find the sine of an angle whose terminal ray intersects at point S. So sine of theta is from point S. So again, notice we've got a radius there. So S, the sine value at S is which one of these two? -y, but we have a dilated unit circle by R. So how do we adjust that to get the sine value? Divided by R. So this is -y/R. And then number 5, a cosine of the angle whose terminal ray is at point Q. So where's point Q? Point Q, we want which one? Cosine. So which cosine value is here? And then the dilation. So the cosine of theta in this case will be -x divided by R. And then the tangent at R. So we need the tangent of theta at this point. Give me the formula for tangent. Sine divided by x. Sorry, sine divided by cosine. So y/x. And what about the dilation? So it's going to be -y divided by R all over -x divided by R. Now the minus signs cancel out, the R's cancel out, y/x. Okay, that's it for today. Have a go with the homework exercises.